Hello, everyone. Welcome back to another Cybersecurity Cybertruck Edition workshop hosted by the Q Project, and my name is Solomon Denning. I'll be doing tonight's lesson about Pi-hole implementation. Last week, we had our other student, Armand, helping teach what Pi-hole was and showing an overview of what it was and how it can be used as an ad blocker. And today, we're going to be actually implementing that ad blocker, hopefully on one of your own personal computers or one within your own home network. So a quick recap of what Pi-hole is. It usually is correlated with Raspberry Pi, but Pi-hole can be run on anything. And it is a DNS sinkhole and a DHCP server. If you would like to know more about that, you can watch our video from last week. But today, for our benefit, we're just assuming that it works and that we're going to be using it as an ad blocker, as it has functionality to be an ad blocker. So the way we're going to be implementing this is not just by running it on your own computer, just inside your own files. We're going to be using Docker. So if you guys don't know what Docker is, it allows you to create images and containers that are cross-platform. They can be given to different OSs, and they maintain all of the information they need within their own image. And so you have images such as Ubuntu, but we're going to be using a Pi-hole image. They actually have their own image. So we would be downloading that image, creating a container and running it, and it will hold every single dependency it needs, and you won't have to worry about it. It will just run in the background whenever you need it to run. The way we're going to install Pi-hole, though, is with Docker Compose. This is just a type of tool that Docker has created that allows us to run multiple images and containers. So Pi-hole actually is pulling from more than just one container, which a container would be a simple task. So obviously Pi-hole is going to need more than one simple task to do its job of ad blocking. So we're going to be implementing, or not implementing, we're going to be using Docker Compose, and it uses a YAML file format. You don't need to know much about YAML, but that's what we're going to be using today, and it should be straightforward. It runs kind of like a script or config file. So this is a detailed list of not all the steps, but some of the major steps. You can go ahead and take a screenshot of this if you would like to save it for later, or when this video is published on YouTube, you'll be able to see the steps again. So the first thing we want to do is visit Pi-hole, because this is where we can get our Docker install file. Or not, yeah, the file, but we're not downloading a file. We're going to be looking at their quick start and saving, copying and pasting a script into our own file. Same thing almost, but just a little more work on our end. Then the next thing we're going to be doing is we're going to be running that Docker script using Docker Compose. That just allows it to be easier on our end. We can do Docker Compose that script and it will just run everything, install it for us. Then the next thing we need to do is we would like to change our password. So we have to execute the Docker file, because currently it will run in a detached mode or headless mode where you don't get to use your command prompt or your bash shell. So we're going to execute the bash real quick, change our Pi-hole password, and then that will pretty much set everything up for you. You'll have your Pi-hole ready to run whenever you want, or to run in the background, and you'll have a simple password for logging into your online web page to view your logs and all that. So with that over, we're going to go into the demo. So let's see. Let me close this. And then what I'm going to do real quick is come over here, type in piehole.net. And so this is the first website you're going to want to visit. We can see there's two different ways of installing it. One is Docker. The other is installing it on your own device. This is really useful if you have a Raspberry Pi, per se, because one of the main intents of a Raspberry Pi is to plug it, leave it, and then to SSH into it whenever you need it. So I'm currently going to be SSHing into a Raspberry Pi, but for the convenience of all of you at home, instead of just installing it on the Raspberry Pi, I'm going to be using Docker because that makes it easier cross-platform, like I was mentioning, for all of you at home to be able to install it and have it run flawlessly, I hope. So we'll click Docker install. It's going to take us to their GitHub page. This GitHub page, you don't need to worry about any of the files. We're just going to come straight down to the quick start. And there's only 2 steps, pretty simple. It's the first one is we're going to copy this information. And then we're going to want to create a file called docker compose.yaml. And I think I forgot to make this clear a second ago. If you're going to be installing Pi-hole this way, you do need to have Docker and Docker Compose already configured on your device. If you don't have those installed, it should be fairly simple to install it. I believe if you go Docker install, this here went straight to installing it for Windows, but I believe if I come somewhat over, let me go back one and go Docker install OS. Okay, you can see there's a Docker install for Windows, for Mac, and then there's also for Linux and all that for those that use it. Fairly straightforward. Then the next thing you need, or this will tell you how to go through installing Docker, and then the next thing you'll need is Docker Compose. Here you can go to install Docker Compose. It will tell you about the same thing for what device, how to install it. But that's prerequisites to what we're doing. We're hoping that you already have that installed. So aside from that little note, we're going to go back to the main guide for today. So here on the Pi-hole GitHub page, we're going to be on the quick start. Copy this script that they gave us to copy, and we're going to create a Docker Compose file. Currently, this here is a terminal, and I'm SSH'd into my Raspberry Pi. You don't have to have a Raspberry Pi. You also don't have to be SSH'd into it. This could just be your normal terminal for your laptop or your PC. So this is obviously in Bash, so if you're using Windows, it may be different. But I'm sure that if you install the Ubuntu shell from the Windows Store, you should be able to do this in a pretty similar way if you install Docker on that Ubuntu shell ahead of time. So I'm going to use Nano since I'm in SSH, and I want to create a docker compose.yaml file. Let's see. So if you guys run this, yours is going to be blank. Mine is not blank just because I already copied and pasted this in previously. So you'll copy and paste it in. And there's one simple fix that you should look for, and that is the time zone. I'm assuming that all of you that are here from UC Merced are living in UC Merced or in Merced area or around in California. So you'll want to change your time zone to Los Angeles because that's the time zone for us. If anyone else is watching this, since this will be uploaded on YouTube, feel free to look up your own time zone and change that so that it works good. Then that's all we need to do. Just copy, paste, change your time zone. We're going to do Control X to exit that. It will ask you to save. You can click Y. Mine was already saved. But now that we have that done, we have the script ready to run. And whenever we want to run it, we will install Pi-hole on our as a Docker image. So currently we're reaching step 3. So to run this script, we can go Docker compose up, and then we're going to run it in detached mode just because that's the way we would like it to run. We just want it to run in the background. So we have Docker compose up, detach. On your guys' devices, it's going to say creating Pi-hole. It's going to make a notice saying we do not have these images. So it's going to start pulling them from Docker's website. That may take about a minute or 2, 3 minutes. Shouldn't be too long. And then since mine's already installed and downloaded, it just says creating Pi-hole done. But what yours will do is it will install it or download, install it, then create Pi-hole. So what is this doing? What it's actually doing is creating the container, and it's already running. It's already up and ready to go. So if we go Docker container list, we'll see we have our Docker container open. So let me zoom out just a little bit so it's easier to see. It may be a little more difficult, but just granted, this is the easiest way for it to be read. But we have your container ID. So below container ID, you'll have a ID. That's going to be useful in pretty much anything you do with Docker. Then you have the image name, the commands. It says it's created, and it also says that it's been up for 45 seconds, which is about when we started it. Another interesting thing about Docker is it allows you to connect ports. So currently what this is saying is it's saying from the Raspberry Pi, we want the port number 53 to be aliased or correlated with the Docker's port number 53. So you're able to connect your ports from Docker to your device. In my case, a Raspberry Pi. In your case, it could be a Windows or Mac computer. But you connect your ports so that the Docker image acts as if it's part of your computer. This allows us to use your computer's IP address and then to go to the Docker file instead, or the Docker container that's running Pi-hole. So let me zoom in again. I'm going to go ahead and copy this container ID because we're going to want to start it, or it's already started. We're going to want to enter it in the bash shell. So you can see the way to do that is Docker execute -it for flags, the ID, and then here we're going to put bash because we would like to use bash. I believe there's other ones. I can't name them off the top of my head, but bash is the most useful one. So you want to indicate execute this as a bash so that I can use bash scripts or bash commands. So Docker execute -it, that container ID's name, and bash. And you can see now we're in another name file called root with the container's ID. This shows that we're now inside of this Docker container that's been running. The reason we want to do that is so that we can change our password real quick. So we're just going to run Pi-hole real quick, Pi-hole -a-p. This gives us the ability to change our password. So I'm going to go ahead and do that. The reason why you would want to change your password is the current one it gives you is a randomized one. And even though that's useful for like debugging, if you want to access this on the fly, you don't really want to have a random set of strings. So I just immediately go in and change the password. You can set it to whatever you want. I won't tell you guys what my password is. Then from here, we're going to say exit. That's all we needed to do inside this Docker image, but you can see ls. There's a bunch of files in here. It's basically its own operating system running, but it is consuming minimal processing power of your computer because it's running as a little container that is using other files rather than creating its own virtual environment. So we're going to exit. And that's pretty much all we need to do here in the command line. So if we come back over here, or actually one last thing you'll need to do, you want to know the IP address of the device that Docker's running on. In my case, it's a Raspberry Pi. And to do that, you do ifconfig. So we'll come down to your wireless. It starts with a W in most cases. If you're using Ethernet, you can go ahead and use your Ethernet one that starts with an E. But I believe this is usually the correct one. Always just go for the one that starts with a W. Grab your IP address. And we're going to visit it. It's going to bring us to this page mentioning that you need to go to the admin panel because there's not really a home page for Pi-hole. You have an admin panel. So it takes you to the admin, and here we are. It's running, and you can see that this is on I am on, Mac OS right now. This terminal here is actually a Linux terminal running through SSH. So you can see that everything's working correctly. This IP address is on my home network and my MacBook is allowed to view it. So we're going to log in. We're going to put the password that I set. You'll put the password that you set. And here we are. We're inside. So the first thing to mention, or some of this was brought up by Armand last time, but I'll quickly go over it. You have your queries and like all your main stats. The main page you usually want to go to is query log. This is going to tell you all of the queries that are being made and which ones are being blocked, which ones are not. I'll come back to this because I'll be able to show some in action queries here. The next thing you'll want to use pretty often is the whitelisting. This allows you to put domains that you would like to whitelist, which means that they'll never be blocked. You can do this by putting the exact domain, or a pretty nice one is a regex filter. So if I put, say, you wouldn't want to do this because there's a lot of ads or there's a lot of things from Google that will prevent your browser from working normally if you regex filter Google. But regex filter in Google basically means anything with the name Google in it is going to be whitelisted in this case. If you regex filter it on blacklist, which blacklist, whitelist, I'm sure you guys understand what that means. But here, if we did this and we regex filtered blacklisted Google, anything with Google's name in it, in the domain, is not going to work. So that's like a basic example of how you can whitelist, blacklist. But before we finish this workshop, because from there you have pretty much everything you need, Pi-hole is running. But there's one last thing, and it's how do we actually connect this to our devices? Because currently I'm able to view this admin page, but my device, my MacBook here, is not ad blocking. So for that, you need to go into your settings, your Wi-Fi settings or network settings, and configure your network to use this DNS IP address. Because technically this is now your DNS. And Armand covered DNS in last week's workshop. So if you want a better understanding of that, you can go watch the previous video on YouTube. But this is going to be your DNS, which means it's going to route all of your queries to the internet, or when you request to get the IP address of a domain name, it's going to go to your Pi-hole application first, which is running on a Docker container. inside of whatever device you're running it in. So let's go to my settings real quick. I'll be able to show you here on Mac how to do it. If you're in settings, you'll go over to network. Then you'll want to go to advanced and then go over to DNS. Currently, you'll have maybe like 1, 2, or maybe the same DNS servers as me. You'll want to change these. So you're going to want to get rid of those and put the one that is for the IP address of your device running Pi-hole. This is mine for my case. Click OK, click apply. And with that, my MacBook is now running it's running its DNS through my Raspberry Pi. So now ads are going to be blocked, which is pretty sweet. If you would like to do that on Windows, it should be fairly straightforward. You can also look up a quick guide to it. On cell phones, it's also pretty similar. So I'm sure that none of you will have issues being able to Google that and find out how to change your DNS. But once you change your DNS on your device, you can see that this client is no longer showing localhost. Anything with localhost is the Docker or the Pi-hole application itself, whatever device it is. But in this case, there's a new IP address here, and this is from my MacBook. And if you look at this here, that also makes it pretty apparent that it's from Mac. You can see that it's calling all these iCloud and Apple DNS things in the background, which technically I'm not a big fan of that, but that's another story for another time. But with that, we'll go back over to the home page. I can show you some last minute things so that you're aware of them. When you're inside your device that's running the Docker container, if you would like to view the containers running, you can do containers list like I did before, or not containers, container, and you'll get all the containers running. If you want if you want every container, even the ones that have been stopped, because you can see here that status is up, so you can stop containers and they won't run, but they'll be ready to run in the future. You can add a -A to that command. And I don't have any currently, so it only shows one again. If you want to view images, you can go Docker images. And the difference, it's a little confusing for people that don't understand Docker, but there's a subtle difference in these. You can think of the images just like you've downloaded the file that contains everything you need, but then to run it, you need to install it, and then it goes and runs itself. So you can always come back to this image to create multiple containers. So I could technically have 5 Pi-hole containers running with all different names and all different configurations based off of this one image. So that's somewhat of the main difference. If you would like to, another quick tip is if you would like to delete any of these, you would take the image ID, you would go Docker RMI with that image ID, and you'll delete it in case you want to get rid of it. It's not going to let me do that because I have a running container. But if my container was stopped, I'd be able to delete the images. As well as if I want to delete a Docker container, I can go Docker container list, then Docker. I can either do Docker RM. I like to do this just to clarify that it is a container, but it should work without putting container. Then you can just select all the containers you want. Then again, this will not work if I run it because my container is running. So the last thing to show you is how to stop a container. That would be Docker container stop. Pretty straightforward. Copy your container ID and paste. It will take a few seconds, and then you'll see that it prints out the Docker ID name. If we go back to Docker container list, you'll see nothing's there now. But if I go to list all with the -A, it shows up and it shows that it exited. I can also show that it exited just by refreshing this feed. No longer able to connect. So pretty great. So with that, I want to thank you guys for showing up to my workshop. Hopefully this helps you guys. Hopefully you guys would like to use this now or in the future. These are the websites that I used. I went over the Pi-hole website as well as the GitHub one. These are videos that I watched. If you would like to screenshot this and visit these URLs, that it may help you. This one was pretty helpful for me if you have issues with Raspberry Pi on how to get Docker Compose installed on it. So with that, thank you all for coming to tonight's workshop. And we're hosting these every week. Hopefully we see you back here on Thursday night. And good night.